solve the difference equation of the discrete time LTI systems using jet transformations. So the heading as so now we'll start the solutions of LCCDE. Solution of LCCDE using jet transformations. Using jet transformations. It's a very simple method, no? So first one is directly you can go for the concept, no? General, all of you know that one. What is meant by the LCCDE? Nothing but it gives the relationship between the input and output with the weights. So the relation generally the general form of difference equation. The general form of difference equation. General form of difference equation of any discrete time LTI system. Of any discrete time LTI system is always equal to the present output is always depends upon the past output, that is summation n is equal to 1 to n, sorry, here it is a k, summation k is equal to 1 to n ak into y of n minus k, this is a past outputs plus present input, that is summation k is equal to 0 to m bk into x of n minus k. So this is about the general form of the system equation, okay, for LTI systems. So generally this the solution is contains the two parts, the response, that is the one is the natural response. What is the natural response? The another name in the first chapter already we discussed about this natural response concept. The another name for the natural response is zero input response, which will be obtained in this case the solution is obtained when input x of n is equal to 0 and it is obtained due to system initial conditions, mainly system initial conditions. System initial conditions. With the help of the system initial conditions, we obtain the solution natural response of the given system. Second one is the forced response. The another name for the forced response is nothing but a zero state response, which will be obtained due to forcing function, that is input. The mainly it will be obtained due to input only, due to input. So these are the mainly solution of the LCCDE using difference equation concept. Now we will go for one example problem directly. With the help of the example problem, we just get the complete how to solve the problems. So if you are having notebooks, please note down that problem. Determine the natural response and forced response. Determine the natural response NR and forced response of the system described by difference equation or LCCDE is y of n minus 3 by 4 into y of n minus 1 plus 1 by 8 into y of n minus 2 is equal to x of n plus x of n minus 1. So this is about the difference equation where the system initial conditions are with the system initial conditions y of minus 1 is equal to 0 and y of minus 2 is equal to minus 1. So this is about the system initial conditions. So this is about the concept of the Okay. So now coming to this one, the solution for this solution. First, the problem in the problem they clearly mentioned the natural response. So all of you know this one. So natural response is nothing but a, for the natural response input, whatever the status of the input, x of n is equal to 0. So automatically x of n minus 1 is also 0. So that y of n minus 3 by 4 into y of n minus 1 plus 1 by 8 into y of n minus 2 is equal to 0. This is the resultant difference equation for LCCDE. Whenever, one thing you can remember, whenever the system initial conditions are given, you just go to the one-sided jet transformations. So according to one-sided jet transformation technique, according to one-sided jet transformation time shifting property for one-sided jet transformations. Okay, according to the one-sided jet transformation, that is time shifting property of the jet transformations. All of you know this one, ma? I think jet transformation of y of n minus 1 is always equal to, in general, actually which is equal to the y of z into z power minus 1. But for one-sided, which is always equal to the y of z into z inverse, y of z into z inverse plus y of minus 1. Similarly, for z transformation of y of n minus 2 is equal to, in general, which is always equal to the y of z into z power of minus 2. But whenever it is go for one-sided, which is equal to the y of minus 1 into z inverse plus y of minus 2. So substitute all these two time shifting property of the one-sided z transforms in the above expression. So y of n is nothing but a y of z minus 3 by 4 into y of minus 1. In place of y of minus 1, y of z into z inverse plus y of minus 1 plus 1 by 8 into, so which is equal to the 1 by z into z power of minus 2 plus y of minus 1 into z inverse plus y of minus 2 is equal to 0. So this is about the after applying the one-sided jet transformation with the help of the time shifting property, this is the final expression, and common for y of z here we can get the 1 minus 3 by 4 into y. Okay, before we can common to the first substitute the initial conditions. What is the given initial conditions in the problem? Y of minus 1 is equal to 0 and y of minus 2 is equal to 1. So wherever the y of minus 1 is there, here y of minus 1, this y of minus 1 is equal to 0 and this y of minus 1 is equal to 0 and this y of minus 2 is equal to, what is the answer? Minus 1. Substitute in place of the system initial conditions, these are the values. Then finally the expression is y of z minus 3 by 4 into y of z into z power minus 1 plus 1 by 8 into y of z into z power of minus 8 minus 1 by 8 is equal to 0. So now we can common to the y of z here, 1 minus 3 by 4 into z inverse plus 1 by 8 into z power minus 2 is equal to 1 by 8. So this is the, actually numerator is not existed whenever the input is equal to 0. At that time that numerator component is existed due to the system initial conditions. That's why this response is generally called as the system in natural response, which is obtained due to the system initial conditions. So actually whenever the input is equal to 0, nothing but the right side completely it is a part is equal to 0. For this one, whenever you can apply the normal jet transformations. Why we go for one-sided jet transformation here is, main reason is when for natural response input is 0. Yes, are you understanding? Clearly observe it. For natural response input x of n is equal to 0. Whenever the input is equal to 0, that complete right-sided part here is 0. Okay, whenever you can apply the z transformation here, y of z is equal to 1 minus 3 by 4 z inverse plus 1 by 8 z power of minus 2 is equal to 0. From this one, y of z is equal to 0 by something, 0. That's why we go for one-sided z transformations here to obtain the solution, where that solution is obtained due to the system natural conditions. Okay, here due to the system natural conditions, a numerator is existed with a value of 1 by 8. So simply now the system transfer function y of z is equal to 1 by 8 divided by 1 minus 3 by 4 into z inverse plus 1 by 8 into z power minus 2. This is the, so now what is the options? Response they are asking, nothing but a natural response. So y of n they are needed. So for this one, apply the inverse z transformation. So inverse z transformation of y of z is equal to, what is the value? Y of n. So before applying the y of z, before applying the inverse z transformation here, first just rearranging the z values. So y of z may be expressed in another form, 1 by 8 divided by, here we can common for z power of minus 2, then you can get the z square minus 3 by 4 into z plus 1 by 8. Convert into the positive powers of z. So you can get the 1 by 8 into z square divided by, so z power of minus 2 is nothing but a numerator, 1 by 8 z square minus 3 by 4 into z plus 1 by 8. So y of z is equal to, now apply the partial fractions. Whatever the roots for this one, for 1 by 8 roots are 1 by 4 and 1 by 2. So that y of z is equal to z square into 1 by 8 divided by z minus 3 by 4 into z minus 1 by 4. Sorry, z minus 1 by 4 into 1 by 2. Sorry, z minus 1 by 4 and 1 by 2. So which is equal to the a by, sorry, before that x, y of z by z we needed. So y of z by z is equal to 1 by 8 into z divided by z minus 1 by 4 into z minus 1 by 2. So which is equal to the partial fractions method. A is equal to z minus 1 by 4 plus b by z minus 1 by 2. So calculate the value of constants a and b here. So for the value of a is equal to, so z minus 1 by 4 into 1 by 8 into z divided by z minus 1 by 4 into z minus 1 by 2 at z is equal to 1 by 4. So 1 by z minus 1 by 4, 1 by 4 get cancelled. From this one, 1 by 8 into 1 by 4 divided by 1 by 4 minus 1 by 2, nothing but a minus 1 by 2 vastundi. So this is the 1 by 32 divided by minus 1 by 2, 16. So answer is minus 1 by 16 is the a value. Similarly for b value is z minus 1 by 2 into 1 by 8 into z divided by 1 by 8 into z divided by z minus 1 by 4 into z minus 1 by 2. This is the another procedure for finding the constants. So z minus 1 by 2, 1 by 2 get cancelled here. So 1 by 8 into 1 by 2 divided by 1 by 2 minus 1 by 4. So 0.5 minus 0.25, 0.25. So 1 by 16 divided by 1 by 2. So 2 1 ja 2 8 ja, okay. So answer is 1 by 8. So z is equal to, a is equal to 1 by 8 and b is equal to, a is equal to, ఏమో ఆన్సర్స్ కరెక్ట్ అని ఒకసారి చెక్ చేసుకోండి. Yes, a value and b value are the right or wrong, I don't know, but please cross check. So here 1 by 4, just whether you are following or not, I don't know. there is a flexibility in the online classroom 4/8. So this is the answer is minus 1 by 8. And similarly for here also denominator 1 by 2 minus 1 by 4, nothing but a 1 by 4 ma. Answer is 2 here. So answer is minus 1 by 8 and 1 by 4 is the A and B values now. So finally that y of z by z is equal to y of z by z is equal to A by, what is the value of A? Minus 1 by 4 divided by z minus 1 by 4 plus B by, sorry, 1 by 8 ma. So it is the 1 by 8 and here it is the 1 by 4 divided by z minus 1 by 2. So from this one y of z is equal to minus 1 by 8 divided by z minus 1 by 4 plus 1 by 4 into z by z minus 1 by 2. Now we can apply the inverse z transformation. After applying the partial fractions, apply the inverse z transformation here. So y of n is equal to nothing but a, which is the called as the natural response minus 1 by 8 into z by z minus a is nothing but inverse z transformation paired with 1 by a power n into u of n. So in place of a here is 1 by 4. So 1 by 4 whole power of n into u of n plus 1 by 4 into 1 by 2 whole power of n into u of n. So this is the natural response of the given system. So this is a procedure for finding the natural response of the given discrete time LTI systems by using the Z transformation. So in the problem, whenever you can remember one thing, in the problem system initial conditions are given, so go for this approach. If the system initial conditions are not given, go for direct normal approach. That is nothing but a forced response. For forced response, what we need? Input we need. So but in the problem there is no given input, clearly observe it. So in the problem there is no mention in the input signal. So we can assume that any one input signal. Here we can assume that any one input signal. Okay na? Either it is a step signal or impulse signal, whatever it may be. That is your choice. Okay. So just I can assume that here. I assume that input x of n is equal to u of n. What is the x of z here? X of z is equal to z by z minus 1 or 1 by 1 minus z inverse. This is the z transformation of the step signal. So again, first go for the given equation y of n minus 3 by 4 into y of n minus 1 plus 1 by 8 into y of n minus 2 is equal to x of n plus x of n minus 1. X of n plus x of n minus 1. So this is the given system equation. So for forced response, generalized you can apply it. General time shifting property. So apply the Z transformation on both sides, because for forced response input is existed and system initial conditions. What about the system initial conditions for the forced response? Which is equal to the 0. So system initial conditions, all the given system initial conditions are 0. Only due to the input we can get the response. So generalized transformation we can apply here. So first y of z minus 3 by 4 into y of z into z power minus 1 plus 1 by 8 into y of z into z power minus 2 is equal to x of z plus x of z into z power minus 1. No need to x of minus 1, x of minus 2, y of minus 1, y of minus 2 here, because all the system initial conditions are goes to 0. So from this one you can just go for y of z is equal to 1 minus 3 by 4 into z inverse plus 1 by 8 into z power minus 2. Here asking the response, not for system impulse response. System impulse response means we need to find the h of n. Suppose if they find the system response, we need to find the y of n value. So here system response that asking, so that no need to finding the system transfer function and system impulse response. So from this one, y of z is equal to x of z into 1 plus z inverse divided by 1 minus 3 by 4 into z inverse plus 1 by 8 into z power minus 2. What about the x of z here? What about the, so before we can apply the z trans x of z, before substituting s of z, first convert into the positive powers of z, because we need to find the y of n here. So for this one, for a partial fraction method, we need to calculate, we need to convert into the positive powers of z. It is the easiest manner. So for that purpose, so z power of minus 2 is common for denominator here. So z square minus 3 by 4 into z plus 1 by 8. So this z power of minus 2 is goes to the x of z into, go for the numerator 1 by z square is the numerator. So we can get the z square plus z divided by finally z square minus 3 by 4 into z plus 1 by 8. Now the complete transfer function of the complete system equation y of z is equal to, what is the x of z here? Z by z minus 1. So z by z minus 1 for input, and ఇక్కడ కూడా z common, where z into z plus 1 divided by z square minus 3 by 4 into z plus 1 by 8. Apply the partial fraction method. The roots are 1 by 4 and 1 by 2 here. So before I can applying the partial fractions method, first y of z by z. So y of z by z is equal to z into z plus 1 divided by z minus 1 into z minus 1 by 4 into z minus 1 by 2. So totally how many values are there? Here clearly observe it. First you can check y of z by is a proper form or not. As proper form, because the numerator order is 2, denominator order is 3. So no problem. Numerator order is less than the denominator order. So the fraction is in the proper form. So that apply the partial fractions method. So first a by z minus 1 plus b by z minus 1 by 4 plus c by z minus 1 by 2. So from this one, first we can need to calculate the a value. For what is the denominator for a? Z minus 1. Z minus 1 into z plus 1 divided by z minus 1 into z minus 1 by 4 into z minus 1 by 2 into at z is equal to 1. So z minus 1 get cancelled. After substituting the 1 here, 1 plus 1, 2 divided by 1 minus 1 by 4. 1 minus 1 by 4, 3 by 4, 1 minus 1 by 2, 1 by 2. What is the final answer? It is the 3 by 8 and totally 16 by 3 is the answer. Okay, this is for a value, and similarly for the value of b is equal to z minus 1 by 4 into z plus 1 divided by z minus 1 into z minus 1 by 4 into z minus 1 by 2 at z is equal to 1 by 4. So z minus 1 by 4, 1 by 4 get cancelled. From this one, 1 by 4 into 1 by 4 plus 1, 5 by 4 divided by 1 by 4 minus 1 minus 3 by 4. Next 1 by 4 minus 1 by 2 minus 1 by 4 minus 0.5 plus 0.25. Okay. So here minus into minus plus 4 get cancelled. Answer is 5 by 3. Next, similarly for the value of c is equal to z minus 1 by 2 into z into z plus 1 divided by z minus 1 into z minus 1 by 4 into z minus 1 by 2 at z is equal to 1 by 2. So z minus 1 by 2, 1 by 2 get cancel. So 1 by 2 into 1 by 2 plus 1 is 3 by 2 divided by 1 by 2 minus 1 by 2, 1 by 2 minus 1 by 4, 1 by 4. 2, 2, 4 get cancel. Answer is minus 6. Answer is minus 6. So minus 1 పైకి వెళ్తే minus 3 అవుతుందా, minus 2 పైకి వెళ్తే. So this is about the values of the A, B, C constants. So finally y of z by z is equal to A by, A is nothing but a 16 by 3 into z minus 1. 16 by 3 into 1 by z minus 1 plus 5 by 3 into z minus 1 by 4. 5 by 3 divided by z minus 1 by 4 minus 6 into 1 by z minus 1 by 2. So from this one y of z is equal to 16 by 3 into z by z minus 1 plus 5 by 3 into z by z minus 1 by 4 minus 6 into z by z minus 1 by 2. So finally clearly observe it. Now we can apply the inverse z transformation. Apply the inverse z transformation. We think all of you know this one. Z by z minus a is inverse z transform pair with a power n into u of n. So apply the some concept, you can get the response. Y of n is equal to 16 by 3 into 1 power n into u of n plus 5 by 3 into 1 by 4 whole power of n into u of n minus 6 into 1 by 2 whole power of n into u of n. So clearly observe it. So this is about the concept of the z transformations applications. So how to solve the difference equations using LCCDE. So generally the solution of LCCDE, from that after solving that LCCDE we can obtain the two responses. One is natural response, second one is the forced response. Generally the natural response is called as zero input response, whereas the forced response is called as the zero state response, which is obtained due to the input, whereas the natural response is obtained due to the system initial condition. So this is the natural response. Input x of n is equal to 0. So here y of n minus 3 by 4. Here where we can apply the time shifting property of the one-sided z transformations, we obtain the natural response. This is the one method. So there is a change in the constants here. Coefficients are changed automatically while we go for forced response. In addition to this, one more response is added. One more term is also added. So this is about the forced response of the given system. So if you are having any doubt, please ask me. So this is about the, and in sometimes examination, so there's a one more problem they are asking, like just they are asking the determine the response. I will give the clarity one more problem. Just determine the response. Determine the response. Determine the response. Determine the response if they mention clearly. Determine the response. Impulse response or step response, they mention clearly. So determine the response if discrete time system, having the difference equation are described by the difference equation y of n minus 3 into y of n minus 1 minus 4 into y of n minus 2 is equal to x of n plus 2 into x of n minus 1. 2 into x of n minus 1 using z transformations. Using z transformation, if input x of n is equal to delta of n. if input x of n is equal to delta of n. This is the problem asking like this one previous problem, no? Where sometimes it may be asking x of n is equal to some 1 2 power n into u of n, or sometimes it may be asked like u of n. So whatever it may be, they give the input. Okay, for our convenience purpose, for our simplification, for our understanding purpose, we go for delta of n simply. Okay, so for this one, how to solve? Here there is not a given initial conditions. Here there is no initial condition, so that no need to apply the one-sided jet transformation of the time shifting property. So we can go for general method. So nothing but a two-sided jet transformation time shifting property you can apply. So y of n minus 3 into y of n minus 1 minus 4 into y of n minus 2 is equal to x of n plus 2 into x of n minus 1. So just we can go for apply the jet transformation. Actually for the same problem, actually it is a forced response now, because input is given. So what is the procedures you have to follow to find the forced response in the first chapter? First we can go for a homogeneous solution, then we can go for the particular solution, where in the homogeneous solutions we can write in the form of y of n is equal to lambda power n, then it will convert it into the polynomial equation, quadratic equation, then find the roots. Based on the roots behavior, you can write the coefficients like c1, c2, c3 like this one. And whereas the particular solution, depending upon the input, there is a particular solution is there. So after adding homogeneous solution plus particular solution, which gives the forced response. There is a lengthy process, but in the jet transformation is a very simple. So y of z minus 3 into y of z into z inverse minus 4 into y of z into z power minus 2 is equal to x of z plus 2 into x of z into z inverse. Enough. So nothing but a next common for y of z here, 1 minus 3 into z inverse minus 4 into z power minus 2 is equal to, and common for x of z here, 1 plus z inverse. Here x of z is equal to 1. Why? Because due to input, what is the input here? X of n is equal to delta of n. So from this one, y of z is equal to, what is the final answer? 1 plus z inverse divided by 1 minus 3 into z inverse plus 4 into z power minus 2. So convert into the positive powers of z. Convert into positive powers. Then we can solve the final answer. You can get the final answer. So apply the partial fractions. So y of z is equal to 1 plus z inverse divided by z power of minus 2 is common here, z square minus 3z plus 4. So finally which is equal to the z into z plus 1 divided by, because z power of minus 2 is goes to the numerator here. So z square avutundi. So z square plus z. So z square plus z can be written as z into z plus 1, z square minus 3z plus 4. So next, so y of z by z is equal to z plus 1 divided by z square minus 3z plus 4. So 4 roots are 4 into 1. So one root is 4, another root is 1. So is there any mistake? Okay, minus 4z inverse. A small denominator here, minus 4, and it is also minus 4 because the roots are different here, that's why. So here minus 4, minus 3 is there, so minus 4 into 1. So according to this one, the roots are, one is the plus 4 minus 4 and another one is the plus 4 plus 1. So z plus 1 divided by z square minus 4z plus z plus 4. So from this one, z plus 1 divided by z common, so z minus 4 plus 1 z minus 4. So finally that y of z by z is equal to z plus 1 divided by z minus 4 into z plus 1. So which is equal to the a by z minus 4 plus b by z plus 1. b by z plus 1. So then find the a and b values. So nothing but a forced response one. So in the examination they ask the like just write the response. So a is equal to z minus 4 into z plus 1 divided by z minus 4 into z plus 1.
Z minus 1 వచ్చింది కదా
z minus
అక్కడ
1.
-4 కదా సార్
Yes, ma, minus
z
4.
minus bz minus.
Okay, here minus 4. Okay. Next, here also minus 4. So z minus 4 minus 1 is common. That's it. Or plus 1. Ma. Ma, I think right it is. Now it is right. Clearly observe
Yes,
it. Ma. So final answer I know the ma, but that's why I'll give the directly answer here. So z is equal to 4 here. So z is equal to 4. We can evaluate this one. Z minus 4. Z minus 4 get cancel. 4 plus 1 5. 5 plus again z plus 1 is also. What is the value of a? Anyone? Is there any change numerator? Okay, what is the problem I can provide it here? One more mistake is there. 1 plus 2 z inverse here. So here clearly observe it, ma. In the second problem, there is a x of n plus 2 into x of n minus 1. So x of z plus 2 into x of z into z inverse. So that here 2 is missing. 1 plus 2 z inverse, 1 plus 2 z inverse, 1 plus 2 z inverse, z into z plus 2, z into z plus 2, z plus 2, z plus 2. So finally now we can answer is 6 by 5 for a value, and b value is equal to z plus 1 into z plus 2 divided by z minus 4 into z plus 1. So z plus 1 cancel, and you can evaluate at z is equal to minus 1, not for plus 1, because z plus 1 z is equal to minus 1. So that minus 1 plus 2 nothing but a plus 1 divided by, again it is the minus 1 minus 4 minus 5. So answer is minus 1 by 5. So one is the 6 by 5, second one is the minus 1 by 5. So finally that y of z by z is equal to a value is 6 by 5 divided by z minus 4 minus 1 by 4 divided by z plus 1. So from this one y of z is equal to 6 by 5 into z by z minus 4 minus 1 by 5 into z by z plus 1. Again you can apply the inverse z transformation now. Apply the inverse z transformations on both sides. We obtain the system solution, that is y of n is equal to 6 by 5 into 4 power n into u of n, because z by z minus a form. z by z minus a, and here also same thing ma, it is also z by z minus of minus 1 అవుతుంది. So nothing but a minus 1 by 5 into minus 1 whole power of n into u of n. So this is the response, forced response. So in the problem they not mention the clearly forced response, just response. If the input is given, that is nothing but a forced response. If the input is not given and system initial conditions are provided, that is nothing but a natural response. That's it. Okay. So whenever you can solve the differential equations, or whenever you can find the response of the any LTI systems using jet transforms, so that is nothing but a forced response. It is a very easy. So in examinations you can follow any one method, either homogeneous and particular solutions or this method. Already this is the same problem we can solve in first unit also. Just go through your notebooks, we can we can solve this problem using homogeneous solutions and particular solutions. The same problem again we can apply here for using jet transformation. So this is the use of the jet transformations method. So if you are having any doubt, please ask me.